Good morning, everybody, and thanks for joining this class on instrumentation amplifier. So I trust that you guys have assembled a breadboard with your instrumentation amplifier as you see it here. Okay, let me just assess your assembly. Okay, Felipe, that's great. Moses, that's great. Oh, it's very tidy. Good job, guys. Now we just have to see if it works. So the breadboard assembly looks very much alike the one that I made for the demonstration. So you basically have one breadboard where you have assembled the differential stage and one breadboard where you have assembled the input stage. Okay, so then I will stop sharing my screen and I'm gonna leave to one of you guys to share the computer screen and show me the demonstration of your board. So who doesn't want to start? Felipe?
Sure. Yeah, sure. I'm going to share my screen now.
Okay. Okay, can you show me?
Okay, so this is the Labrador board.
Yes.
This is the oscilloscope 1. Oh, sorry,
Yes.
2.
So yeah, you don't have oscilloscope channel 2 is not connected.
Is this one?
Nope. If you look at the pinout, channel 2 is on the other header.
So this one is the
Yep.
2?
Yes.
Let me go back to the... Now here, this should be the 1 and it's connected to the second one, to the input.
Yes, I can see.
And this is the other one that is connected to the output.
Yes.
Of the same stage. So I'm going back to the Labrador board, and now I can see that everything is synchronized, which means I have a...
If you look at the pinout, I'm going to share my screen now. So you see that's the pinout of the Labrador board. So the first header
is the first oscilloscope.
Is oscilloscope channel 1. The second header is oscilloscope channel 2.
Okay.
And you have some duplicate pins in case you need to connect more things. And you should use signal generator channel 1 DC if you want to make sure that you are conveying the offset to the input.
Yes, okay, that one I have it right. And yes,
make sure that you have the ground of the Labrador board connected to the middle of the power supply.
Is that next to the 3.3 volts?
Yeah, is the second pin going down, counting on the header from the direction as oriented in my screen from the micro USB connector.
Yeah, okay, yeah, I have it here.
Okay. So let's see now I'm stop sharing this. And I'll leave you for your screen. Okay, you see that now? Yeah, I can see your assembly.
So here is channel 1, which is connected to the signal generator.
From the Labrador board.
Okay. So this is it.
Okay. So now both channels are exactly the same as expected.
Yes.
Because your amplifier is gaining 1.
Yes.
And doing the difference between the ground and so okay, now we have a problem because your differential stage is not amplifying.
So I'm going to move it to the total output.
Oh yes.
Again, it's 1 for this one.
Yes.
So this is the total output.
Okay, perfect. Now we see something. Okay.
2.5.
Yes. So it is saturating a little bit, or it might be just an artifact of the trigger, because the trigger is on channel 1. You might want to put the trigger on channel 2.
Yep.
Yeah. Okay. So now you could measure the peak-to-peak value of the output here. So
how can I do that?
may I suggest you to remove the offset from channel 1, Felipe, from the input?
How can I do it? From
so
here?
If you put the offset to 0, if you go signal generator channel 1, yeah, and put the 0, yes, and retrigger, please.
It looks like it still have something there.
Yes. That's because the input stage has some offset.
Okay.
So that is the reason why we are taking all these measurements, because now what we can do, we can measure the offset of your input stage for the non-inverting input. We can measure the gain for your non-inverting input channel. Then you can do, leaving the same settings of your signal generator, switching the role of the inverting and non-inverting input.
Okay.
And then you should connect both inputs
to the
same signal generator, and you can measure the common mode gain. And then you can fill in your lab report.
Okay. So this is how it looks when I use the same signal in both channels.
Yes. So as you can see, you have some DC offset there.
Yes.
So what you need to do to measure it properly, you need to magnify. Well, now you have a problem with the trigger because you are triggering on channel 2, which is flat. You should trigger on channel 1.
And yep. I'm going to put it up to.
Yes, you can actually use the mouse to measure. Yeah, but you don't need to use the mouse because it is actually almost 0.2. No, sorry.
Yes.
0.05 or something.
Yes, it looks like it's 30 millivolts.
Yep, that's fine because you know what is the amplitude at the input. You know now the amplitude. Yeah, exactly, 30 millivolts. Perfect. So now you can have you measured your common mode gain. I'll leave you to measure the differential gain of the other input because that goes on your lab report. And now we can switch to Moses to do the same.
Okay. All right. So I'm going to stop sharing. Thank you.
Thank you, Felipe. Okay, Moses, up to you. So I can see your breadboard there. That's good. Oh, that's still Felipe, sorry. Let me just move it. Yep. Okay, I can see your breadboard there and your Labrador board. Yeah, also your assembly look very tidy. So if you want, you can start sharing your Labrador board output. So like Felipe, have you removed the gain resistor to do a gain of 1? Oh, that's perfect. So that is the same kind of measurement I have shown into the demo.
Correct.
So then that means that in your case, we don't need to debug anything, and I'm just looking forward to see your lab report with the measurement of the differential gain and the common mode gain and also the common mode rejection ratio.
Yes.
It seems that you don't have any problem. So
I had a jump start. I had to prepare for the class, so I spent some hours.
Yes, I can see that. But I can see, so the gain look quite big. Yeah, that's good. So you probably have done a bit of selection on your resistors because it look way better than mine.
What I did was just to measure the resistors to use the ones that were closest to each other.
Okay, so you selected the one that were a bit more matching for your differential stage.
Yes.
That's perfect, guys. I think that we can close the session
Stop sharing.
because, yeah, if you can stop sharing. So I'm looking forward to see your lab report.